Hello everyone, this is a problem video for section 10.2. So I'm going to start with the online homework, and then if I feel like you guys need some more examples, I'll do some more examples after the homework. Okay, so most of these, there's a lot of straightforward ones. So let's just cover some of the kind of low-hanging fruit. Let's say we have x equals, well, let's see, do we need to do the graphing one? Okay, so I'll skip the graphing for number one. Let's start with number one, but I'm going to skip the graphing. The graphing should be pretty straightforward. It's, just about making that table t, x, y. You plug, you pick some values for t in this range, and then you plug them into your equations, and you get your x values and your y values. Okay, and then you just graph these x, y points and then connect them together. And the more points you do in your table, okay, the more exact values you get, the clearer your picture is going to be of your graph. So, I haven't even looked at this graph yet, but maybe let's say I graph 2 points, and the 2 points are there. Well, it's not very clear what this graph looks like, right? It could be a straight line connecting these points, or it could be like a parabola. Okay, but if I drew a bunch of points, maybe I drew, or maybe I plotted, several points, okay, I would get the picture that this is some sort of curve like that. Okay, so don't be afraid to do several points. Let's skip right to part B, where it says find a rectangular coordinate equation for the curve by eliminating the parameter. Okay, so rectangular coordinates, I believe in my videos I called them Cartesian coordinates, same thing. What they want is they want you to write this, they want you to write x as a function of y, or y as a function of x. Okay, so let's skip right to that part. Okay, so how do I find that? I'm gonna look at one of these equations and solve for t. Okay. Now, when I see like x equals t squared, I want to stay away from that equation. I don't want to solve for t in that equation if I can avoid it, because if I solve for t, okay, I get square root of x equals t, but really it's plus or minus square root of x equals t, right? Um, so it's unclear which one of those I should use. So there's a little ambiguity there. So I would prefer to solve for t in this equation, okay? And that's pretty easy. Okay, I get y plus 2 equals t. And then I take this value for t and plug it into this equation, okay? And I get this, x equals y plus 2 squared, okay? So that's my rectangular equation. And then it also asks for, so number one asks for bounds on x. It wants x between two values, right? Just like t is in between two values. So basically what you do is you just plug these t values in to x to get your range of x. Okay. So when I plug t equals 2 into this, I get 4. And when I plug in 4, I get 16. Moving on. Again, we have, let's see, x equals 4t, y equals t plus 2. So pretty basic set of parametric equations. I'm not going to graph them. And then, okay, this is one of the ones where, there's no squares, no even powers in this. So I could really solve for t in either of these. I could do x over 4 equals t and then plug that into here. Or I could do it the opposite way. I could say, well, y minus 2 equals t and plug it into there. Okay, so there's two ways to solve this one, and I'll show you both. So let's take this and plug it into our y equation. When I do that, I get y equals x over 4 plus 2. Okay, so that would be one answer. That would be a final answer. Or I could say y minus 2 equals t from this equation, and then plug that into here. And I would get x equals 4 times y minus 2. So x equals 4y minus 8. Okay. Both of these would be acceptable answers. Three, now we're getting into the fun stuff, doing some calculus. X equals t sine of t, y equals t squared plus 7t. I want to find, and the problem is to find dy dx. So this is all just about memorizing this formula, that it's dy over dt over dx dt. Okay, so I need to find dy dt, dx dt. Right? Okay, so dy dt is what? 2t plus 7 dx dt equals, okay, I got to do product rule here, right? So that would be what, sine of t plus t cosine of t. And then dy dx would be this divided by this. And that would be our final answer. Equation of the, so let's do one of these, equation of the tangent lines, and then I'll start skipping some problem. I'm not going to do the whole homework for you. Okay, so let's look at number 4 now. This is a tangent line problem. So we're given x equals t minus t to the negative 1, y equals 2 plus t squared, and we want to find the equation of the line tangent to this parametric curve when t equals 1. Okay, so what is that saying? These parametric equations give that we can draw a parametric curve, right? And maybe, and this is just I haven't graphed this curve or anything, so this might not be an accurate drawing, but let's say at time equals 1, we're at that point. Okay, time equals 1. And then we could plug time equals 1 in, t equals 1 into these equations, and we would get like an xy point, right? XY coordinates. And there's a line tangent to this curve, and we want to find the equation of this line, like in y equals mx plus b form. Okay. Now, if we find dy dx, that's going to give us the slope of this line, right? The m. And then how do we find y equals mx plus b? Well, remember that there's a couple ways to write the equation of a line, right? We have point slope form, right? Okay. This form where xo, yo is just some point on the line. Well, we know this xy point, that's on the tangent line, right? So we can plug t into these equations and find a point on our line. And if we find dy dx, we'll have all the information we need to write a line in this form. And then all we need to do is rearrange to get the y-intercept form, slope-intercept form. Okay, but first step might be finding, well, we can find the point, right? When I plug t equals 1 into my equations, what do I get? I get x equals 1 minus 1, so x equals 0. I get y equals 2 plus 1, so 3. So I know this point 0, 3 is on my line. Okay. So I know my point slope form. Okay, this thing is going to be y minus 3 equals m x minus 0. Okay, so all I need to do is find this slope. Okay, just remember what the slope is. Slope is just going to be dy dx. Okay, so last piece of information I need to find is dy dx. And I know how to do that, right, from my equations up here, my parametric equations. That's going to be dy dt over dx dt. Okay, so what's dy dt? Let's see, dy dt is going to be 2t. And then what's dx dt? That's going to be 1 plus t to the negative 2. Okay, you guys can check this yourselves, differentiate these. And then what am I going to do? I'm going to take t equals 1 and plug them into this. Okay, so dy dx at t equals 1. Well, I'm going to plug 1 in here, and I get 2 over 1 plus 1 equals 2 over 2 equals 1. So my m is 1. Okay, so now I have all the information I need to write my point slope form. I get y minus 3 equals 1 times x minus 0. And then I just rearrange to get slope intercept form. Okay, final answer. Numbers 5 and 6. Let's see, number 5 is the same thing. We need equation of a tangent line. It asks you to do it a couple different ways. They should give you the exact same answer. 6, again, finding the equation of a tangent line. 7 brings us to some new stuff, the concavity stuff. Okay. So let's see. In my example, they give us x equals e to the t. This is number 7. Y equals t e to the negative t. They tell us to find dy dx. They tell us to find d squared y over dx squared. And then they ask us, okay, where's our curve concave upward? And they say interval. They want it in interval notation. Okay. So before we do concavity, we gotta find second derivative to find concavity. So let's start with these derivatives. Okay. What's dy dx? Well, that's going to be dy dt over dx dt. Okay. So what's dy dt? Differentiating this, we get, let's see, e to the negative t minus t e to the negative t dx dt. That's just going to be e to the t. So let's simplify this. It usually helps a lot to simplify at this stage before finding second derivative. Okay. And really, you should be able to see that now. Maybe it requires a bit of explanation. But remember how to find the second derivative, this d squared y over dx squared. We got to differentiate this thing with respect to t, right? And then take that answer and divide it by e to the t. So the hard part would be differentiating, we divide by the derivative of this thing, dx dt. So the hard part would be differentiating this piece with respect to t. Okay, if I don't simplify, it's going to be quotient rule, right? It would be like et squared, and I can do it this way if you're comfortable with that way. It should give you the exact same answer. But if I did quotient rule, it'd be et squared over e to the t times derivative of all this, blah, 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 minus e to the t times e to the negative t, blah, blah, blah. Okay, so complicated. Let's see what happens when we simplify first. Okay, let's give ourselves some room here. Okay. So if I simplify this thing, I'm just going to divide this et out. So I'll get e to the negative 2t minus t e to the negative 2t. Okay. And now I take the derivative of this with respect to t. And what do I get? Okay, so I'll write it here, dt of dy dx let's see. So derivative of this with respect to t, that'd be -2 e to the -2t. See, minus, I need to do product rule on this bit. Let's see. Okay, and then simplifying again, you know, combine all this stuff. Okay, this is my first step in finding the second derivative. And then next, I need to just divide this by dx dt, right? And that should give me the second derivative. So d squared y over dx squared, it's going to be this thing divided by, what was our dx dt? Just e to the t. And then I can simplify this some more. Okay, so minus 3e to the -3t. Well, before we simplify, let's kind of look at our concavity problem. Well, we could simplify, or we could not simplify. Let's go ahead and simplify and see what happens. Okay, if I simplify, this becomes -3e to -3t plus 2t e to the -3t, which is what? So this is my second derivative. And to figure out where my curve is concave up, that's going to be where the second derivative is positive, right? So I want to figure out where this thing is positive. Well, e to the -3t, that's always positive, right? Okay, so I got a positive, and then I'm multiplying by this. So our second derivative will be positive. Okay, so this is positive. Our second derivative will be positive if this thing's positive. Okay, so when is that thing positive? When is 2t minus 3? When is that greater than 0? Okay, just solve this inequality. 2t is greater than 3. T is greater than 3 over 2. Now, this is an inequality. How do I write it in interval notation? Okay, think about if you drew the number line, boom, boom. We would have 3 halves here, and t is everything, you know, to the right of that, not including this 0.3 halves. How do you write that in interval notation? 3 halves to infinity. Okay, and again, we never want to include that point there. Okay, so it's always a parentheses, not a bracket, and on infinities we always have parentheses, right? So this is our interval notation. I feel like a lot of the problem people have for concavity is finding out, you know, maybe they can find the second derivative, but then at this step, solving here to figure out when the second derivative is positive is hard. So let's just try a couple of just that last piece. Let's say, I'll just give you some examples. Okay, so let's not worry about, let's say we got a problem and we found the second derivative. Okay, and then let's say the second derivative is like t squared minus 4 over, let's say t cubed plus 7, something like that. Actually, let's do 8. This is a good one. All right. How can I figure out when this thing is positive? Okay. There's a special technique you guys can use when we have like our second derivative as a fraction. Okay, so here we have a fraction, right? We got some t's on top, we got some t's on bottom. All right, what technique can we use? What I'm going to do is I'm going to draw a number line. And I'm going to look at the numerator, okay? And I'm going to find where the numerator is 0 for what values of t. Okay, so what values of t is this numerator 0 for? Well, that'd be -2 and +2, right? And what about the denominator? When is that thing 0? And actually, let's change this a little bit to make it a bit better. How about this? 27. Okay, so let's say we have this. So we found where the numerator is 0. Where's the denominator 0? Well, denominator is going to be 0 at -3. Okay, so I plot all these points on my number line, and these are the only points I plot. Okay, so this divides my number line up into these sections, right? Let's see, I got this section, 1, 2, 3, 4. I got 4 sections. So now all I do is I'm going to test each section. By test, I mean I'm going to pick some point. Let's start with this left section. I'm going to pick some point in there. I'm going to plug it into my second derivative. And I'm going to see if that number is positive or negative. So just pick a convenient point. Let's say we pick -4. -4 is in this left section, right? I plug -4 into my second derivative, and what do I get? I'll get, let's see, 16 minus 4 over, let's see, -64 plus 27. Is this number positive or negative? Well, let's see, I got a positive number on top over a negative number. So this is going to give me a negative number, right? All right, so I tested a point in this section and I found it was negative. So that's going to be true for that entire section, okay? So my second derivative is negative in this left section. And now I'm going to repeat that process for all these sections, okay? So let's say I pick 2.5, okay? That'd be in this section here. And I plug it into my second derivative. What do I get? Okay, 2.5 squared. Let's see. Well, that's going to be a positive number. And then, and then I plug -2.5 in there. And that's going to also be a positive number. So I have positive over positive. So this section is going to be all positives. All right. Now let's try this section. Okay, so what's a number in here? Well, 0's in there. 0 is a convenient number to use. So let's plug in 0. And I get, let's see, -4 over 27. That's a negative number. So everything in this section is going to be negative. And then last, I just need to test this right section. Okay, so I pick a number in here. Let's say 3. And I'll get 9 minus 4. Okay, that'd be 5 over, let's see, what, 54, positive number. So this section's all positives. Okay. So now I can tell exactly where my function is concave up, where it's concave down. My function is going to be concave up on these positive sections, and it's going to be concave down on these negative sections. So how would I write my region where it's concave up? Well, I do this interval, -3 to -2. Then I put a big U in the middle for union. I do this interval, which is 2 to infinity. So that would be my region where this curve is concave up. So again, I didn't tell you what the curve was, but I said, okay, that's the second derivative. Where's it concave up? It's going to be here. So hopefully that helps. All right, let's continue on with the homework. Let's see, looking at the homeworks. Number 8 looks like the exact same thing as number 7. Number 9, let's see, finding the points where our tangent is horizontal and vertical. Okay, so all you got to do is, this is really easy, I covered this in the lecture video. To find where our tangent lines are horizontal and vertical, you find dy dx, okay? And let's say it's a fraction. Let's say it's t squared minus 4, and we can use the same example, t squared, well, let's change it up a little bit. Let's say we have t squared minus 4 over t cubed minus 27. Our tangent is going to be horizontal, okay, where the numerator is 0. Okay, so where is that? That's at -2 and +2, right? And then our tangent's going to be vertical when the denominator is 0. Okay, and let's see, that would be, where's this denominator equal to 0? That'd be at 3, +3, right? Now this is the t values, okay? If they want x and y values, let's say you were given, okay, you were given some parametric equations, x equals f of t, y equals g of t, okay? These are the t values where our tangent is horizontal and vertical. To find the x and y values, you would just plug these t values into these equations, okay? So if I wanted to find, okay, what's the xy point that goes along with -2? I just plug -2 into my function for f and -2 into my function for y. That's going to give me some coordinates. Okay, that's one of the points where my tangent is horizontal. So I don't think we need to go through that. It's pretty straightforward. Number 10 is, all right, where does the it gives you some parametric equations. Ask where does that set of parametric equations have tangent with slope 1? Okay, so let's do this one real quick. I have x equals 4t cubed. This is number 10. I have x equals 4t cubed, y equals 5 plus 16t minus 8t squared. And they're asking, all right, where's the tangent? Where does it have slope 1? So first thing to do is find dy dx. Okay, what is dy dx? That'd be 16 minus 16t over 12t squared, right? And they're asking, where does this equal 1? Okay, you're just gonna solve this equation, right? This is an equation here. We're gonna solve for our t value. So how could you do that? First thing I would do is multiply both sides by 12t squared. You get this. And then move everything over to one side. Okay. And then this is a quadratic equation. We could do quadratic formula or factoring. Let's see if I factor out 4, we get 3t squared plus 4t minus 4. And then can we factor? I'm horrible at factoring. If I got something like this, I would just do quadratic formula. So let's see, -4 plus or minus 16 minus 4 times 3 times -4 all over 6. $12, 48, 16 plus 48, that's 64, right? So 4 plus or minus 8 over 6. So let's see, -12 over 6 and +4 over 6. So our t value should be 2 and -2/3. So these are the t values when our slope is 1. How do we find the x and y coordinates where our slope is equal to 1? I'll just plug these values into my parametric equations. Okay, so when I do that, let's rewrite our equations here. I'll copy them at least. Sure, why not? Okay. These are our parametric equations. These are our t values when slope is 1. I want to find the xy values when the slope is 1. So I'm going to take 2 and plug it into these. So I would get x equals 4 times 8 and y equals 5 plus 32 minus 32. So x equals 32 and y equals what, 5. I just realized a mistake. This should be -2, right? So I should plug -2 into these equations. Okay, and then in that case, I would have 4 times -2 cubed. Okay, so this should be -32, and then when I plug -2 into here, what do I get? See, I get 5 minus 32 minus 32. So 5 minus 64. That's what, -59? Yeah. So the xy point that corresponds to this value of -2, that'd be -32, -59. And then there's another point, right? There's the point that corresponds to t equals -2/3. So again, I would just take t equals -2/3 and plug them into my parametric equations. Hey guys, let's continue with the homeworks. Let's look at number 11, which is actually it's an arc length problem, right? So I didn't cover this in my lectures, and you're not supposed to be seeing problems on it. I don't know why this is included in the homework. Don't worry about for test 2. Shouldn't appear on test 2. There's just so when we so I'll just kind of show you how to get through this homework. All right, so don't worry about this too much. So for y equals f of x, we had a formula for arc length, right? Let's say we had x's between a and b. The formula was the integral from a to b of 1 plus f prime squared, right? But f prime is the same thing as dy dx squared. So this is the formula for like Cartesian equations, arc length. And we have another formula for parametric, and really it's the same thing. If you rearrange this and do some chain rule stuff, you get this formula for arc length of parametric functions. Okay, and it's actually very, very similar. Order doesn't matter, but it ends up just being square root of dx dt squared plus dy dt squared. And then I'm integrating in terms of dt. And then let's say if they give me like t between a and b, those would still be my bounds. Okay. So let's look at number 11, because number 11 is a problem like this. I am given, in the version I'm looking at, x equals 7 cosine t minus cosine 7t, and then y is equal to 7 sine of t minus sine of 7t. Okay. And then for t between 0 and pi, we want to find the arc length. Okay. So I'm going to use this formula here. So I need to find dx dt, dy dt. Okay. Let's start with dx dt. That's going to be what, -7 sine of t, and then plus 7 cosine of 7 sine, 7 sine of 7t. So that's dx dt. What's dy dt? 7 cosine of t minus 7 cosine 7t. So these are my dx dt, dy dt. I plug them into my formula, and I get something kind of complicated. Oh, and I need to square these, right? So before we even plug them in, let's square them. Okay. So this problem's kind of a pain. It's got a lot of algebra in it. Okay, a couple trig identities. So when I square this thing, let's square dx dt first. Okay. That would give me what? 49 sine squared t minus 49 sine of t times sine of 7t plus 49 sine squared 7t. All right, so that's dx dt squared. What's dy dt squared? Well, that'd be 49 cosine squared t minus 49 what? Cosine t cosine 7t plus 49 cosine squared 7t. All right, so let's take these and plug them into our equation, our formula. Okay, integrating from 0 to pi. Then I'm adding these together, and before I'm not going to write these all out again. We can use trig identities to combine this stuff, right? I'm adding this top line. Oops, I erased stuff. I'm adding this line to this line. Okay, so let's look at this kind of term by term. 49 sine squared plus 49 cosine squared. Well, that's 49, right? Okay, boom, boom. And then I have, let's see, 49 sine squared of 7t plus 49 cosine squared of 7t. That's another 49. Okay. And then I have this stuff. Okay, minus 49 sine t sine 7t minus 49 cosine t cosine 7t. All right. How do I deal with this? Well, there's some trig identities I can use. Let's combine these. 98, okay, minus 49. Let's kind of factor it a bit. It'll be easier to see if I factor this like so. Okay, so I have this term. Look at this stuff here. This is basically sine of A, sine of B, cosine of A, cosine of B. And there's some trig identities for that stuff, right? So this stuff in parentheses is equal to, and if you don't know it off the top of your head, don't worry about it. I don't memorize this stuff. I look it up when I need it. So this would be, let's see, what would this be? This would be, it looks like cosine of A minus B. So cosine of 6t. And maybe the way you do it, you get negative 6t. Okay, but that's fine. Cosine of 6t and cosine of negative 6t, those are the same thing because cosine is an even function. So what I have is now this. Okay. And let's factor out a 98. If I factor 98 out of this, well, I get 1 minus cosine of 6t. Let's leave this positive 6t in there. 1 minus cosine of 6t over 2. And maybe this looks familiar to it. This is, I can undo this with the half angle identity or whatever. Remember, think about it backwards. What's sine squared of 3t? Use double angle identity. That's 1/2 times 1 minus cosine of 6t, right? Okay. So let's see, let's replace this then with this, 2 sine squared 3t. And, oh, and then I got a 98 as well, right? 98 times 2. Okay. So when I take the square root of this, let's see, I can bring the 98 through. It becomes 7 square root of 2 square root of 2. So this becomes 28, I believe. 20, yeah, 28 sine squared 3t dt. All right, we have to be careful. We, you know, in 7.3, we just kind of said, okay, square root and square, this trig stuff cancels. And it does in this case too, but we have to check our interval. Meaning like, okay, on this interval, sine of 3t, is that always? No, it's not always positive. Yeah, so this is an example of why we got to be careful here. Sine is not always positive on this interval, right? So sometimes this square root would be, yeah, we got to be careful about this square root. Okay. Technically, when I take the square root of this, okay, square root of this square, okay, technically it becomes absolute value of sine of 3t, right? And on this interval 0 to pi, sometimes this is positive, sometimes it's negative. So how can I do the integral of this this absolute value? Think about sine of 3t. Okay, it'd be positive. What does the graph look like? Sine of 3t. It's going to be kind of scrunched together. Okay, so at pi over 3, it's 0 again. Okay. And then 2 pi over 3. And then this would be pi. Okay, so I want to find this total area. Okay, but these things are all the same size. So really what I can do is, instead of doing integral 0 to pi of absolute value, I can do 0 to pi over 3, and then multiply that by 3. And then just drop the absolute value. Okay, so I have this. Pull the 28 out, and then the rest is just integrating. Let's see, so 3 times 28. I integrate this, and what is it? It's negative cosine 3t over 3 from 0 to, this should be pi over 3, 0 to pi over 3. Okay, I evaluate this, and I get 3 times 28 times, let's see, negative times negative 1 over 3 minus negative 1 over 3. Okay, and I just spotted a mistake that this 28 should be a 14. This square root of 196, so this is 196, right? And the square root of that is 14, not 28. Okay, so these are all 14s. And then this is 2/3. So what I have is 3 times 14 times 2/3. 3's cancel, I'm left with 28. So this problem's a bear. So if you can follow along and replicate that, great. If not, if it's just a total bad time, I'm trying to avoid cursing. If you're just not having fun with it and don't get it, don't worry about it too much. You're not going to see something like this on the test. But if you have some free time, take a stab at it. 12 and 13 seem more straightforward. 14 is, let's see, similar to, I mean, it's arc length of parametric stuff, but it's a lot easier in that, seems a lot easier anyway, in that they just ask you to set up the integral and then plug it into a calculator or some, solving software. Okay, so that should be pretty straightforward. 15, finding equation of a tangent line, so straightforward. 16, concavity, we've covered that. 17, more parametric stuff, but again, it's just the parametric arc length stuff. But again, it's just setting up the integral and plugging it into a calculator. So that should about cover section 10.2. And I think I've covered all the topics I wanted to cover for this section. So let me know if you have any questions.